Why use a local node? A local Kaspa node provides dedicated resources for various operations such as mining, minting, or basic transactions like sending and receiving. Unlike public nodes, where you must compete for resources, a local node ensures a smoother experience, especially when the network is overloaded. This helps you avoid unnecessary waiting times and additional fees to get your transactions into the nodes in the mempool. What does this tutorial include? In this tutorial, you'll learn how to quickly install a local node. You will explore the available options. You'll also see how to test it using a WASM example. After that, we'll set up your KRC20 minting app to utilize the node. Let's start by accessing the Rusty Kaspa GitHub repository and downloading the necessary files. In the README, you'll find instructions on how to build from source. But if you just want to install it, head to the releases section. Choose the release you want. I'll use the latest version for Linux in this example. I copied the link to the zip file. Back on my computer, I'll create a folder for the node and use a get to download the zip file directly to my server. Next, I create a folder called TN10 where the node will store its files. This can be helpful if you want to start the node at a more advanced state rather than from the beginning, as syncing with peers can take up to 40 minutes. After unzipping the file, you'll see a folder containing Kaspa.d, the executable file for the node. Let's check the available options by running Kaspa.d help. As you can see, there are several options for testnet 10. You'll need to use the UTXO index option for wallet operations. And you can also limit memory usage. You can use the net suffix option for testnet 11 as well. Let's execute the binary Kaspa.d with the options I chose. I am using ampersand symbol at the end to run this process in the background. That way, if I accidentally close my terminal, it will continue processing. I can use FG to bring it back to the standard output and Control+C to stop it. Let's check the files the node has created inside the TN10 folder. We have the logs to verify if the node is processing blocks. There are also the data files. I will move an old TN10 folder I used previously so I don't have to wait for 40 minutes for this node to sync 100% and start processing blocks and transactions. As you can see, the node has started processing blocks and is ready to be used. The ports are also up and ready to receive connections from wallets or for my KRC20 app. To test the local node, I will use my KRC20 app that I demonstrated in the last video. Since my KRC20 app is using WASM, I'll take this opportunity to download the same release as the node. This is a good practice. I'll go back to the Rusty Kaspa GitHub repository, navigate to the releases section, and copy the link for the WASM zip file. I will move the current WASM folder to an old folder. Let's unzip the file and copy the content of the Node.js directory into our new WASM folder. Even before that, if you don't want to install the KRC20 app, you can directly use an example from the WASM files with Node.js as follows. We'll use resolver.js, and we'll make some changes to point to the local node at the local host and at 72.10 port, which is the Borscht RPC port. Oops, we need to run node init first. Now we can test the connection. It has created a random wallet address. The connection is working, and we are receiving information from the node such as block count, difficulty, and more. Now, let's do a KRC20 minting using the local node. We'll use tchimp, the same ticker we used before on testnet 10. We need our private key to sign the transactions. For more information, you can check the app documentation in the repository. More details are available in the description. Let's first check that we have everything we need, including the correct minting format for the data. We'll use the random key I created before in my last video and check if there's still some balance. Let's verify that the gas fee is correct. And then modify the RPC connection to use the local node. Let's prepare to check the result of the minting in the Kasplex indexer API. Now we can execute the minting. No extra fees are needed for this process. Let's check the reveal transaction. And we're done. As you can see, the process works smoothly using my own local node. I hope you found this content valuable. Don't forget to subscribe to my YouTube channel for more tutorials and insights like this. Also, be sure to follow me on Twitter to stay updated with the latest developments in this technology and beyond. Let's keep exploring and learning together. Until the next time, cheers.